Good morning. Today we are going to learn about methods of analysis for collected climatic data. So far in this semester, you have collected the climatic data and tried to arrange it in a proper format. Now we are trying to analyze it through a graphical and a statistical method. For that, first we need to understand what is the design process that follows. So process. To study and understand the climate and its impact, architectural responses needs a systematic data collection and analysis and interpretation method. Okay. So data collection is done. We are now on analysis. Statistical method of analysis that is done through Mahoney's table, and graphical method is done through a bioclimatic chart. After this, we are going to arrive at a conclusion and chart out or draft some design strategies that will suggest some necessary changes in the building enclosure as well as configuration and orientation with response to climate. After that, you implement or execute that design on the site. So this is a process that is followed, and we are at a second stage, that is analysis. It basically compares predominant climatic conditions and human comfort level. Whatever we are doing, the final aim is to make an architecture or an indoor space which is comfortable to humans as well as which responds to the climatic factors. So human comfort level comes first, where you are designing for humans, you are designing a user-centric space. Comfort zone for humans under various conditions is majorly a physiological comfort. Here we are talking about physical and thermal comfort. Physical comfort means what your body feels in any certain microclimate. Okay, so whatever ventilation your room is getting, whatever temperature you are experiencing in certain space, defines or impacts your comfortable condition. We will see how. Okay. Results of analysis govern the selection of design strategies suited to the respective climatic zone. The systematic assessment of climatic data enables designer to give an appropriate and logical design solution suited to the local climate. Okay. So let us see how concept of comfort is narrated, or in our climatology, how comfort zone or human comfort level is defined. So our body, human body, is continuously conversating with its surroundings, with its climate or immediate surrounding. Okay. So we are perspirating, we are continuously exchanging the heat with the surrounding. Okay. So there are certain ways where we lose and gain energy in the body. Is one through body metabolism, whatever the activities or digestion, you're running, or are you performing any work and breathing, it all creates an energy or heat in the body. So that is the first source. Second source is radiation. Okay. Another heat losses or gain are done by respiration, that is convection and evaporation. Then clothing is an important factor. We lose heat by radiation through a long wave radiation. Convective currents again affect the body temperatures. And lastly, evaporation. And some part is also which comes in some part of the body which comes in contact with things, different things, maybe floor, maybe some anything, a chair or a table, anything which comes in contact with your body, we exchange heat with that surface through conduction. So these are the means we keep conversating or we keep exchanging the heat with our immediate surrounding. Okay. So let us read about human thermal comfort. Human thermal comfort is defined as an expression of satisfaction with surrounding environment. Okay, where you feel comfortable, where you feel satisfied with the surrounding environment, that condition is called as human comfort, thermal comfort. High temperatures and humidity provide discomfort sensation, and sometimes heat stress. Okay, heat stress is the exhaustion of body due to excess heat. Okay, and when body cannot cool itself by perspirating, it causes discomfort due to heat, like we experience in Nagpur while summers. Moreover, discomfort and heat stress reduce productivity of workers, or efficiency of work, and may lead to more serious health problems. Humans generally feel comfortable between the range of temperature of 22 degrees Celsius to 27 degrees Celsius, and relative humidity is comfortable well within the limits of 40% to 60%. Okay, so these are the basic concept of human thermal comfort for which we are designing an enclosure. Now let us see how graphically and technically we can chart and plot a comfort zone for human being. Psychometric chart gives you an exact and precise charting of comfort zone in any climatic zone that you are studying. So it is basically plotted against dry bulb temperature on x-axis and wet bulb temperature on the lines inclined to the horizontal that along the saturation curve. And on y-axis you will find dew point temperatures or humidity ratios also are marked on y-axis. And then you have relative humidity. So if you have this basic data, you can plot and get a comfort zone which is suited to your climatic zone. This is how the diagram looks. It gives you a precise idea about comfort zone in any climatic zone that you have been studying. It also gives you an idea about what are the strategies that should be followed in any climatic challenges. Okay, so here the demarcated gray area is denoted by comfort zone. Okay, so this chart is based on the readings of dry bulb temperatures, wet bulb temperatures, relative humidity, and dew point temperature. Also, it gives you an idea about the enthalpy. So collectively, it forms a geometry which gives you precise idea about comfort zone in any particular climate. And if you see, with increasing levels of humidity and decreasing levels of temperature, and all the combinations are possible here. Okay, so in total it gives you approximately 15 to 18 combinations for which you can very well predict and give a perfect diagnosis of your comfort zone and strategies to bring your natural setup or natural climate in towards that comfort zone. Okay, so this is just for understanding of comfort zone. Again, if you see this second diagram, it essentially says you if your comfort zone shifts in any particular direction, what are the strategies that are required. And the second one shows you where are the probable locations of climate of comfort zone in different climates. Okay, we have seen and we have been collecting the data for various climatic zones. And if you see, and if this study is pursued in detail, you can plot a comfort zone, and you'll see that this diagram shows you the exact range of temperature as well as humidity that should be in any indoor climate in any climatic zone. Okay. Also, the range of conditions which at least 80% of the people would feel comfortable can be termed as comfort zone. Okay. So surveys are conducted, and any particular space is called is within the comfort zone if 80% of those surveyed samples or those surveyed people say yes, they are comfortable. So comfort zone has very much importance when we talk about bioclimatic chart and Mahoney's tables. So yes, we will move ahead to the next topic, which is bioclimatic chart. Now, bioclimatic charts are charts which basically these are tools to plot your dry bulb temperature and relative humidity and recommend any design changes or any changes in the microclimate of indoor to be done. Okay, so it recommends you or it suggests the addition of heat or removal of heat So heat loss is required or heat gain is required. All those ideas are given by bioclimatic chart. Let's read about it. This is how it looks. Okay, it is placed. It is charted against relative humidity on x-axis, that is RH, which is measured in percentage, and across you will see dry bulb temperature, which is measured in degrees Celsius. Okay. There is a indication of comfort zone, and there are also certain lines which indicate various properties that that help you in designing as per the climate. So let us read about it. What is a bioclimatic chart? It's a preliminary analysis tool used during the early planning stages of a building project. It is known as bioclimatic architecture, an architecture which uses bioclimatic chart to design buildings that include the most efficient passive cooling or heating strategies based on the climate and location. Bioclimatic charts are used in assessing the effectiveness and selection of passive cooling or passive heating. These charts are based on the typical dry bulb temperature and humidity extracted from typical meteorological years, TMY. So typical meteorological years मतलब यहाँ पे जब climatic data हमने collect किया था, so we said कि why to collect only 1 year's data. There is data available for hundreds of years. Okay, so last 50 years में जो behavior pattern रहता है किसी भी climate का, उसे हम उस लोकेशन का क्लाइमेट कहते हैं. ठीक है, अदरवाइज अगर सीजनल है या कुछ छोटे ड्यूरेशन के लिए तो उसे वेदर कहते हैं, राइट. सो TMY टिपिकल मेट्रोलॉजिकल ईयर्स जो होते हैं वो अप्रोक्सीमेटली 50 to 70 ईयर्स का ड्यूरेशन होता है. उस ड्यूरेशन में जितनी रिलेटिव ह्यूमिडिटी एक्सपीरियंस की है किसी भी एक लोकेशन में वो हम चार्ट करते हैं ऑन दिस टेबल. ओके, सो मंथली डेटा इज चार्टेड और से एक किसी भी एक दिन का डेटा चार्ट कर सकते हो आप अगर किसी स्पेसिफिक डे का आपको कंफर्ट लेवल्स टेस्ट करने हैं. ओके, these chart facilitate the analysis of climate characteristic of a given location, ठीक है, from the viewpoint of human comfort, as they present on psychometric chart the concurrent combination of temperature and humidity at any given time. This is very similar and parallel to psychometric chart as it uses temperature versus humidity and defines a comfort zone. Okay, so bioclimatic chart is even simpler tool to use. They also specify building design guidelines to maximize indoor comfort condition when building's interior is not mechanically conditioned.